Hi, my name is Tatiana Rapinski. I'm the team leader for AGLE, and we're based out of Baltimore, Maryland. This competition is designed to make it easier to monitor your health at home. Our team is an interdisciplinary team consisting of students from a variety of majors: mechanical engineering, software engineering, science, biomedical engineering. There's two advantages to being a student team. We are doing this project not for a paycheck or part of a company. We're doing this because we're wildly enthusiastic about the project, and I believe that enthusiasm and excitement is going to translate to our competition submission. Secondly, because we're new to the field, we're not bound by the status quo in healthcare, and as a result, we're poised to create very innovative solutions. The greatest challenge has been to develop a system that is consumer friendly. We are conducting usability testing. We are developing prototypes and then testing them to see how usable they are, how a person using them feels about it, and taking that feedback to modify our system. Our technology is a multi-part system designed to both tackle the diagnostic challenges as well as the usability specifications. The diagnostic component makes use of things like microfluidic chip and color change test strips. We have a vitals monitoring device, which is continuously worn, and then the smartphone application, which serves as the user interface. Our technology could really change the way that consumers view their own health. So if they're feeling sick, they can immediately know if it's something that they need to be worried about.
My name is Elia Aronoff-Spencer. I'm the team leader of the Distributed Health Labs at UC San Diego here in the United States, California. So in 2006, I showed up to a small hospital, and we haven't released or really even fully settled on what the Tricorder Qualcomm entrant will look like, but we know what we call our global Tricorder, which is our stack. We know what that looks like, and we're going to have to reconcile those two. But I think in the end, there's pretty much zero losers here. I think everybody who showed up today kind of already won. I mean, this is you got to.
My name is Dr. Japheth Doswell. We are Team Juxtopia Imhotep from Baltimore, Maryland, USA. Team Juxtopia Imhotep is comprised 100% of students. Most of the students are from the city, Baltimore City, Maryland. The students' age ranges from middle school, high school, as well as college-age youth. Currently, we have 5 students. The advantages of having a student team is that, one, they're hungry. They really want to do something that's very innovative, think outside the box. The pure innovation, eagerness, and propensity to learn is there. The disadvantage is that they do not have the experience as a seasoned professional. The work with the Google Lunar X Prize Challenge has definitely influenced our work with Juxtopia Imhotep. There can be crossover technologies from the Google Lunar X Prize competition to the Qualcomm Tricorder Challenge, specifically in the sensing technologies. Matter of fact, our 16-year-old student, the youngest student on the Google Lunar X Prize team, came up with her own spectrometer design to be integrated into the robot and identify water on the lunar surface. My mother was an educator, my father was a social worker. I'm the only child, so they put a lot into me to engineer the person that's talking to you today. Had a great experience growing up and was exposed to so many things that I think contributed to my intellectual, social ability, and providing that same experience for other youth that otherwise would have had that in their own family. I think it's a contribution that all of us should think about making, especially creating the next generation of youth that should be better than the previous generation.
I'm Austin Russell. I'm the team leader for Luminar Technologies, based up in the Bay Area by Stanford in the US. I started at a really young age, sort of getting really interested in some aspects of computer science and software development. Then sort of moved on to some of the electrical engineering, computer engineering aspects of that. Did a bit of independent contracting at this time. This is a few years ago when I was really young, about 10 or 11 at that time. And since then, though, and over the past 4 years or so, I've gotten really into specifically photonics. We can add whole other dimensions of information when you manipulate light over just purely, let's say, acoustic or electrical phenomena. For the past few years, I've been focusing on developing some various new imaging technologies. They're called LiDAR and hyperspectral imaging systems, both of which are high resolution and in real time. The LiDAR system that I was developing, it's able to measure not only sort of an X and a Y axis of a field of view like a regular camera, but also a Z axis, as in the depth of each pixel within the individual image. So you have an entire high resolution depth map that can span distances even up to a kilometer. The second sort of imaging modality that I also we're developing is a real-time hyperspectral camera system that's actually able to identify the molecular composition of all the objects within the field of view completely in real time. It's able to send out a very short pulse of light into the environment to 2 million different locations, all in 1/60th of a second. There are current systems that exist that do this. However, unfortunately, they're extremely costly, often tens, even hundreds of thousands of dollars. Also very bulky, about the size of, maybe this large, the size of like a mini fridge, you could say. So right now we have it down to the size of a few pennies. I definitely see how a lot of these technologies that were originally presented, decades ago, some of the original Star Trek episodes, can actually be realized today. It's definitely sort of a great foreshadow for what's to come.
My name is Dr. Anita Goel. I'm the chairman and CEO of NanoBioSim, based in Cambridge, Massachusetts. Winning the X Challenge by Nokia has been wonderful for us because it actually helped bring us out of stealth mode. For over 20 years, my own research has been at the intersection of nano, bio, and physics, and the Tricorder represents the synthesis of not only the nanosensors like we've developed in the Nokia X Challenge, but the integration of that into a platform. My parents had emigrated from India. I was born in Massachusetts, and when I was 3, we moved down to this little rural town called Prentice, Mississippi. And on the one hand, I loved physics and mathematics, and on the other hand, my dad's a surgeon, so I used to spend a lot of time with him in the operating room. And by the time I was 8, I thought I was already an MD. In a lot of the traditional medical diagnostics, they're more based by the disease system or the infection or the target, and less by an underlying principle of diagnosis. What we're doing in my company at NanoBioSim is we are actually building a next generation platform for that kind of diagnosis, the same gold standard, but in a mobilized platform that enables you to take that ability of diagnosing disease outside of a hospital or centralized pathology lab and bring it into a doctor's office, people's homes, in even rural remote villages in the developing world. If you look at what Google did for the internet and what the advent of cell phones did for the telecommunications industry, they decentralized access to that commodity, so they empowered a lot more people to have access to that. And there are 4 billion people today on Earth who don't have access to basic health care. So my belief is if we can scale technologies like our gene radar affordably on a large scale and decentralize, mobilize, and personalize it, we have the ability in our lifetime to give those 4 billion people access to health care like they've never had before.
My name is Lambert Ninteman, and I'm team captain of SDSU X Team from San Diego, California, USA. When I was 12 years old, I was diagnosed with Hodgkin's disease. At the time that I received chemotherapy, they actually used mustard grin, which is liquid mustard gas, which is what was used in the trenches of World War I. Within a week of being diagnosed, the cancer had metastasized through my entire neck and torso. It was really that difference of a week that changed everything, because back in the mid-'80s, a cancer diagnosis was usually a death sentence. Seeing other kids in the pediatric oncology unit with a whole variety of different cancers, being one of the only ones to come out of it, that really gave me such a deep appreciation for how precious and valuable life is, and imagine how many family stories could be changed if they had that little bit of extra time that was needed to detect something early enough to do something about it. I actually watched Star Trek during chemo because it was one of the things that could take my mind off of being sick, because you can be somewhere else and not be in the pain and the suffering. I, like probably every other Star Trek fan, had an idea of how to make a tricorder happen. And the day that I was accepted into the MBA program at SDSU, I discovered the Qualcomm Tricorder X Prize. It was the planets aligning. It was at that moment I said, well, of course. And this is when I can do it, and this is how I can do it. And from the second I stepped foot on campus, I started working on building SDSU X Team. We've already finished our first prototype, and in fact, we have a technology demonstration coming up in a month where we're going to show the world what we can do. How is it that technology has changed so rapidly in so many fields, from warfare to personal communications to entertainment, and yet for access and delivery of healthcare, we're still in the 19th century? I can only imagine how many diseases, how many things can be learned from this. Everything is going to change. The number of lives that will be impacted is just unimaginable.
My name is Michel Nadeau. We are Team Tactio Vital from Canada and California. I actually founded a company to do network diagnostics, and we were successful in very large networks. The word tactio is the sense of touch, and we decided to make it that word for two reasons. We wanted to design software with no keyboards and no mouse, just use with the finger, with the simplicity of finger, and that was the beginning of the iPhone actually, those times. The other thing is, once you take all the information about your body and you bring it into some form of a screen or something, you get more connected to yourself, and we thought the sense of touch was actually something interesting. I think mobile health is changing the whole business model. A lot of people see mHealth with all the paradigms of the current healthcare system, which is very curative, very driven on the hospitals and the information that the doctors needed in the hospital to be digitized. I think mHealth is all about providing a totally different experience and reversing all that pyramid with the patient as being the center of this whole new healthcare system. We needed some biosensing technologies to help us. We were working with several popular, biosensors for physical activity and all kinds of things, and some blood pressure cuffs and all that. But we wanted something a little more closer to the body, or maybe within the body, or something very, very close to spend a lot more in the chronic diseases area. So far, we have done a lot in a lot of different chronic diseases, obesity, hypertension. We've done diabetes management, working on the COPD and CHF. So we're working various chronic diseases one by one. And I think for the tricorder to be effective, it needs to be something that can scale to very large population levels to actually achieve enormous outcomes and change healthcare. Our expertise is really, and our technology is centered around the scaling, the platform, and all the software required for that. Combined together, we have a solution, I think, which is very compelling for a very broad scope of chronic disease management and diagnostics.
My name is Tom Furness, and I'm the team leader for the Vigilant team in Seattle, Washington. My background is a varied background. I spent the first 23 years of my career designing fighter cockpits for the military. It's just like the change that happened in the telephone system, where we had to depend upon a switchboard operator to make our calls, to patch us into another call. The paradigm shift that took place was to make everybody a telephone operator, where we dialed our own numbers. And that's what I think the tricorder will do. It makes all of us physicians in a way. Here is a prototype of our technology. This is called the Orca. It uses our Chroma ID technology. And inside of this device, and this particular configuration of it, we have 12 emitters that emit the photons. For example, you can place this on your skin, you can put it over your ear, you look at it with your eye, and each time you do this, you get the photons that are sent out probe what's going on. And then with the detectors that we have in here, the light detectors that go all the way from infrared to ultraviolet, will tell us what are the photons bringing back. From that, we are able to discern with this collection of data, and we can search our databases and determine what conditions exist in the patient. One of the problems with the practice of medicine now, especially with physicians, is they generally don't see the patients until they're sick, and they don't have a good baseline necessarily of what the patient's like when they're well. This way they will have that and be able to look at the differences. I'm really concerned about the old people. I'm concerned about the lives they have. We're able to extend their lives, but what about the quality of their lives? I know that my mother had conditions that, had they been diagnosed earlier, she may be still alive today. And I hate the way that my mother spent her last 3 years on the earth. And it was really sad. And I think about my grandchildren and what kind of life they're going to have. And that I don't want the same thing to happen to them. I don't want the same thing to happen to me. And so I believe that there is a revolution happening along with the technology that gives us mobility, to combine that with the measurement tools that basically puts the same kind of instrumentation that the doctors are using into the hands of the people.
I'm Ian McCulloch. I'm the technical lead for the Zensor team from Ireland. Our focus within the Zensor team is to speed up diagnosis and treatment of patients. Using the technology that's available to us, we believe that we can do that. We can reduce hospital stays. Our focus is to try and push technology into the user's home so that they don't have to stay in hospital as much. That saves money for the hospitals. It also makes things a lot easier for the patient. They can go about their daily routines, they can know that they're being monitored and not have to worry about the illnesses that they're suffering from. Our team came together about 18 months ago. We had a specific product in mind from our company, which was to integrate ECG, respiration, motion, temperature, and integrate all those vital signs to produce a home monitoring system. The team itself consists of hardware engineers, software engineers. We have a clinical team. We also design and develop the sensor part, the electrodes. I've been doing this for eight years. A lot of the infrastructure just did not exist. Today you have mobile phone technology, which is basically like a computer in your pocket. So we have it's kind of a lightweight, compact monitoring device. Couple that with the electrode technology, the device picks up your vital signs and the device makes a decision for you and tells you the course of action to follow. People are not getting diagnosed quick enough. One of the arrhythmias that we specifically look for, which can be a precursor to stroke, in many cases it can be fatal if these things are not picked up quickly. With our specific technology at the moment, we will not diagnose any diseases. So we approach the physician as if this is a tool to actually help them diagnose any illnesses. We don't take that decision away from the doctor because we're there to help with the diagnosis rather than take over.
you.